Looking at each of these two terms, 18x and negative 9 are both divisible by 9. The top one requires a 2x and the bottom requires just a negative 1. So 9 is the GCF that was distributed, and 2x minus 1 is the binomial. That's the factored form. 9x and 12 are each divisible by 3. 9x needs a 3x and 12 needs a 4. 3 is what was factored out, and 3x plus 4 is what that would have to be distributed to. 5v to the fifth and 15v cubed and negative 10v. Those each have a 5 and a v that they are divisible by. The top one would need a v to the fourth, the middle would need a 3v squared, and the bottom would need a negative 2. So 5v is what was distributed to v to the fourth plus 3v squared minus 2. Four x to the second and negative 4 are both divisible by 4. The top one needs an x squared and the bottom one needs a negative 1. So 4 is what was distributed, and x squared minus 1 is what it was distributed to. Now, this problem actually can be factored further, but not with what you know so far. So in another day or so, you'll know how to factor that more. Okay, now we have 4 terms. We always want to start by looking for a big GCF, something that can come out of all those terms. But 5, 20, 6, and 24, those don't have a common number that they're all divisible by. And since the 24 doesn't have an x, they don't have any variables in common. So this is where we jump to like step 4 in that process, where we're going to create a sum. So we're going to group the first 2 terms together and group the second 2 terms together. And then look for a GCF coming out of each of those. So if I have 5x to the fourth and 20x cubed, those are each divisible by 5, and they each contain at least an x cubed. The top would need an x and the bottom would need a 4. So I take out the 5x to the third and I leave in the x plus 4. Then I look at 6x and 24, and those are both divisible by 6. The 6x would need an x and the 24 would need a 4. So I'm going to factor out the 6 that they have in common and leave behind the x plus 4. Then I look for the binomial GCF. Notice how the first half of the problem and the second half of the problem both contain an x plus 4. So I'm going to factor out the x plus 4, and that leaves behind a 5x cubed in the first term and a plus 6 in the second term. That pair of binomials is the factorization. Looking at 4x cubed, 8x squared, negative 5x, and 10, they don't have a numerical GCF because of that 5. It's not all divisible by 2. And the 10 doesn't have a variable, so there's no variable GCF. So we go straight to creating the sum. We're going to group the first 2 terms together and the second 2 terms together. Remember, we always write this as an addition problem, creating a sum. Then we take the GCF for 4 cubed and 8x squared. So we have to figure out what that is. Well, both of those terms is divisible by 4, and they both each have an x squared. The 4x cubed needs one more x, and the 8x squared needs a 2. So we factor out the 4x squared, and we have an x plus 2 left behind. Negative 5x and negative 10. Well, since negative 5x has a negative, we're going to pull the negative and the 5 that they're both divisible by. That would require the top to multiply by x and the bottom to multiply by 2. So I factor out that negative 5, and it leaves in the parentheses an x plus 2. And I notice that they have this common binomial factor of x plus 2. So I factor out the binomial that they share, and I create a second binomial from the 2 terms that are left behind. Now when I look at this last one, I notice that those are all even numbers. So they have a 2 as their big GCF. So the first thing I'm going to do is pull a 2 out of everything. So I've got 6x cubed plus 5x squared minus 18x minus 15. Now, that 2 in those big brackets are basically just going to stay on the outside of the problem all the way through all the work that we're going to do. They'll have no further impact. We're now going to the point where we create that sum. So we have 2 times the 6x cubed plus 5x squared will get grouped together, and then we will add to it the negative 18x minus 15. So we work on those 2 inside problems just like we've done with all the others. They don't have any numbers in common, but they do each have an x squared. So this would need a 6x and this would need a 5. So I'm going to factor out the x squared that they share and leave a 6x plus 5 inside the parentheses. And then negative 18x and negative 15, well, those each have a negative and they're divisible by 3. This top would need a 6x and the bottom would need a 5. So I factor out the negative 3 that they have in common, and I leave 6x plus 5 in the parentheses. Now notice they have a binomial factor in common. Since they have a binomial factor in common, I can factor that out. So I still have this 2 outside here. I can drop these big parentheses now. I'm going to have the 6x plus 5. And the other factor will be from the remaining x squared and negative 3. Since each of these 3 things is multiplying, I don't need those big parentheses, those big brackets anymore to separate that off from other things. All right. As I look through, there's a lot of variables in this one, but there isn't a variable that's in all 4 terms, and there isn't a number that's in all 4 terms. So there's no big GCF to take out of everything. So I'm going to go straight to the step of creating the sum. So 2ax plus 6xc plus ba plus 3bc. And just as before, we're going to list the 2 terms. So I've got a 2ax and a 6xc. Well, those are each divisible by 2 and x. Top needs an a, bottom needs a 3c. So I factor out the 2x and I leave behind the a plus 3c. Then I have a ba and a 3bc. So those just have a b in common. The top is going to need an a, and the bottom is going to need a 3c. So I factor out the b, and it leaves behind an a plus 3c. Notice these have that common binomial factor, so I can factor out the a plus 3c, and that leaves behind a 2x plus b. Looking at this next problem, 17 is a prime number, so there aren't any big GCFs here. They don't all have a particular variable in common. So I would look to try to create a sum. So I'm going to group together the 3x to the 4th minus 9x to the 3rd and the 17x plus 5. And I'm going to look at those things. So 3x to the 4th and negative 9x to the 3rd, those have a 3 in common and they have an x cubed in common. The top will need yet another x and the bottom will need a negative 3. So I've got a 3x cubed being factored out and an x minus 3 being left inside. Now when I look at 17x and 5, we might feel a little bit puzzled. 17 is prime and so is 5. The only thing that these things have in common is a 1. And that's going to leave a 17x and a 5 as the other thing they need. So I can factor out the 1, and that gives me 17x plus 5. But here's the issue. Those don't match. So this is not factorable. We can't go any further because they don't have a GCF in common. That means that this original problem was prime and can't be factored. All right, we have a few more straight factorizations. So let's see, I don't see any big GCFs. It doesn't look like there's anything that they all have in common. So we'll go straight to grouping. We have y squared minus 5wy plus 4y minus 20w. So looking at y squared and negative 5wy, those each have a y. The top needs another y, and the bottom needs a negative 5w. So we factor out that y that they share, and we have y minus 5w inside. Let me look at the other two terms, 4y and negative 20w. Those are both divisible by 4. The top needs a y, and the bottom needs a negative 5w. So we factor out the 4, and that leaves us with a binomial of y minus 5w. These have a common binomial of y minus 5w. So we can factor out that GCF of y minus 5w, and that leaves behind a second binomial of y plus 4. Looking at this next polynomial, I notice that every single term has an x. They don't have any numerical factors in common, so I'm going to factor out a big GCF of x. That's going to leave x cubed minus 8x squared plus 12x minus 24. And then we can start the process of creating the sum inside. So we have x cubed and negative x squared as one binomial, and the other one is 12x minus 24. So we pretty much just carry along the x in the big bracket. We're going to look at x cubed and negative x squared and see that they have an x squared in common. The top will need an x and the bottom will need a negative 8. So we've got this x outside the bracket, and we're factoring out an x squared and leaving x minus 8. Then we look at 12x and negative 24. We can see that those are both divisible by 12, and that the top will need an x and the bottom, will need a negative 2. So we factor out a 12, and we leave inside an x minus 2. And we go, these binomials, those are not the same, so we can't factor them out. So that means up here, that was the best we could do. The original problem is not prime, but we can't factor it any further than where it currently is. So we look at this next one. I'm noticing an f in all of the terms. So I'm going to factor out that big GCF. And then we can group to create a sum, AC plus AD plus BC plus BD. And then we can look at each of those pairs. So AC and AD each have an A and then one additional variable. So we've got the F in the bracket. We're factoring out an A and leaving in a C plus D. And then we look at BC and BD. Those each have a B, and they leave C and D behind. So I'm going to factor out a B, which gives me C plus D in parentheses. Those two binomials are the same, and we won't need the big brackets after this because it'll be all multiplication. So F times the binomial they have in common times the binomial that leaves behind. All right, one last problem. We have a little word problem. A helicopter landing pad or helipad is sometimes marked with a circle inside a square so that it is visible from the air. What is the area of the shaded region of the helipad below? All right, this is another one of those donut problems where you have the area of a big thing and you need to subtract off the area of the small thing. So if you imagine the square, right, because we're going to have the area of the square minus the area of the circle, that'll be the part that they actually have to paint red. So the area of a square is a side times itself, so that's 2x squared. The area of a circle is pi r squared, but our r is an x, so that's going to be pi x squared. So we have the formula 2x all squared minus pi x squared. Well, when we multiply 2x by itself, we get 4x squared, then minus pi x squared. And we're asked to give our answer in factored form, so we need to look for a GCF. Notice that each of these terms has an x squared in common. When you factor out that x squared, it leaves a 4 and a negative pi. So that's the area in factored form.